Hey everyone, welcome back to the Quantum Kitchen. Today we're putting on our chef hats for a really special review session.
That's right, today we are cooking up a 5-star review of everything we've covered this quarter. Think of this as your final prep time before the big dinner service, your upcoming assessment. By the time we're done here, you're gonna feel super confident and ready to totally ace it, so let's get cooking.
All right, first things first. Any great chef knows you can't cook a thing without your ingredients. Well, in chemistry, our ingredients are elements and compounds. So let's start by making sure our pantry is fully stocked with the basics.
So an element is the simplest, purest ingredient you can possibly have. Think of it like flour or salt or sugar. You just can't break it down into anything simpler and still have it be that same ingredient. It's one of the fundamental building blocks for everything we're going to cook up here in the Quantum Kitchen. And here are just a few of those pure ingredients, our elements, that you might see on your test. You've got sulfur, iron, oxygen, strontium, and aluminum. Every single one is a unique, pure substance, just like the different jars and containers you'd find in a chef's pantry.
Okay, so what happens when we start combining those pure ingredients? We get a compound. But listen, this isn't just about mixing things together in a bowl. The elements have to chemically combine to create something brand new, with totally new properties. It's kind of like taking flour, eggs, and sugar to bake a cake. You don't have flour and eggs anymore. You've created a cake. It's a whole new thing.
And you know what's a perfect example of this? Baking soda. I mean, look at his formula, NaHCO3. That tells us it's made of sodium, hydrogen, carbon, and oxygen, all chemically bonded together. You can't just pick the sodium out of it anymore, right? It's become a completely new substance.
So, if compounds are our finished dishes, how do we know what's in them? Well, we need to learn how to read our recipe cards. And in the world of chemistry, we call those chemical formulas.
Reading a chemical formula is actually a super simple 3-step process. Let's use sodium sulfate as our example here. First, just identify the element symbols, so we see Na for sodium, S for sulfur, and O for oxygen. Easy enough. Next, you look for those little tiny numbers. They're called subscripts. They tell you how many atoms of the element right before it are in the recipe. And then finally, you just count them up.
So let's do it. For sodium sulfate, that little 2 next to Na tells us we have 2 sodium atoms. Now the S, it doesn't have a number, and whenever you don't see a number, it just means there's 1. So, 1 sulfur atom. And that 4 next to the O, yep, that means 4 oxygen atoms. See? Simple as that. And this is cool because we can use this skill to compare different recipes and figure out which one is the most complex. By just adding up the atoms for each substance, you can see really clearly that phosphoric acid, with a grand total of 8 atoms, is the dish made with the most individual parts.
All right, chefs, you're doing great. Our pantry is stocked, we know how to read recipes, so now it's time to talk about the difference between prepping your ingredients and actually cooking them. This is all about physical versus chemical changes.
Okay, so a physical change is basically just prep work. You're changing how something looks, but not what it fundamentally is. Breaking an egg, grinding an almond, freezing a popsicle, it's still an egg, it's still an almond, it's still popsicle juice. But a chemical change, that's the real cooking. It creates something entirely new. Once you cook that egg, there's no going back to a raw egg. Same thing with burning wood or when iron rusts. A new substance has been created.
Okay, time for a quick little pop quiz. Let's say you write a secret message on paper using lemon juice. When it dries, it's invisible. But then you gently heat the paper and the message appears in brown. So what do you think? Is that a physical or a chemical change?
If you guessed chemical change, you are absolutely right. It's a chemical change because once that message appears, you can't make it go away again. The heat actually caused the lemon juice to react and form a totally new brown substance. You've basically cooked the message right onto the paper.
Excellent work. You guys are nailing this. Okay, for our final course, we're going to master the art of combining ingredients perfectly. And to do that, we need to look at mixtures and solutions. Have you ever made sweet tea or lemonade and you keep adding sugar and eventually it just starts piling up at the bottom of the glass no matter how much you stir? That's because you've created a saturated solution. The stuff you're dissolving, the sugar in this case, is called the solute. And a saturated solution just means the water has dissolved the absolute maximum amount of that solute it can possibly hold at that temperature. It's totally full. All right, I've got one last chef's challenge for you. Picture this. You take a spoonful of sugar and a spoonful of pepper, and you stir them both into a glass of water. The sugar seems to just disappear. but the pepper just floats around. What in the world is going on here? The answer comes down to one key word: solubility. Sugar is soluble in water, which just means it has the ability to dissolve and form a solution. The sugar is definitely still there, you just can't see the individual crystals anymore. The pepper, on the other hand, is not soluble, so it doesn't dissolve. It just keeps its physical properties and gets swirled around.
And you know what plays a huge role in solubility? Temperature. Just look at this. It's so clear. You can dissolve way more sugar in warm water than you can in cool water. That heat gives the water molecules more energy to get in there and break apart those sugar crystals.
So let's go back to that glass of sweet tea with all the sugar at the bottom, that saturated solution. What could you do? Well, you could heat it up. Heating it will almost always allow that extra sugar to finally dissolve, which makes your solution even more concentrated. And just like that, chefs, we're at the end of our review session. We have covered all the key concepts, from stocking the pantry with elements, all the way to mastering solutions. I really want you to remember this. Every great chef knows their fundamentals. You've put in the work today. You've reviewed the recipes, you've practiced the techniques. You know the difference between an element and a compound. You can read the chemical formulas, and you know what happens when you prep versus when you cook. You are so ready for this.
And with that, I'm going to leave you with one final thought. The world of chemistry is like a giant cookbook, just full of the most incredible recipes. Now that you've mastered these fundamental techniques, what amazing new combination, what new recipe will you be inspired to discover next? Now go get 'em, chefs!